So, your house is too hot, or maybe it's too cold. What's the first thing you blame? Probably your furnace or your AC, right? But what if the real problem isn't the machine in your basement? What if it's the house itself? In this explainer, we're going to peel back the layers on a house that looks just about perfect to show you why sometimes you have to look past the HVAC system to find the truth.
Take a look at this place. I mean, on the surface, it looks fantastic, right? Great curb appeal, nice landscaping. You'd never guess it was hiding some pretty serious comfort, efficiency, and even safety problems. We're going to go on a little diagnostic journey to uncover exactly what's going on. All right, here's how we're going to break this down. We'll start with that perfect-looking exterior, then we'll dive in and uncover the hidden flaws. After that, we get to the real truth with some cold, hard data, and trust me, the numbers are shocking. Finally, we'll look at the plan to actually fix it and what that all means for the home's equipment.
Okay, let's begin where everyone else does, right at the curb. From the street, you would see absolutely zero red flags. I mean, you see this solid brick, the nice porch. Everything looks perfect. If you were just some salesperson, you'd measure the square footage, sell them a big new AC unit, and call it a day. But man, that would be a huge, huge mistake. Because the real story isn't what you see on the outside.
All right, to really figure out what's going on, we gotta go where the secrets are hiding. And that means heading up into the attic and down into the basement. This is where the real problems live. And wow, does this tell the story. On the left, you've got that picture-perfect house. On the right, well, that's what's really happening right over their heads in the attic. Let's get in a little closer. Okay, look closely here. You see the tops of those wooden beams, the ceiling joists? That is a huge red flag. The insulation is old, it's been trampled on, and there's just not enough of it. So in the winter, all that expensive heat is just pouring out of the house. And in the summer, that scorching attic heat is just blasting right down into their living room. So we're out of the attic, and now we're heading down to the basement. And boom, we find our second big clue. You might just look like any old water heater, but this is what we call a natural draft appliance. And that can spell trouble. So what does that even mean, natural draft? Well, think of it like this. It relies on hot air rising, kind of like a chimney, to push all the nasty exhaust fumes, we're talking carbon monoxide, safely outside. But here's the kicker. If the house has pressure problems, and trust me, this one does, those deadly gases can get pulled back into the house instead of going out the chimney. This is a huge safety issue. Okay, so seeing this stuff is one thing, but we can't just guess. We need proof. We need cold, hard data, and that's where the real diagnostic work begins. We stop guessing and we start measuring.
So this cool-looking thing is called a blower door. We stick it in the front door, and it's basically a giant, powerful fan that sucks air out of the house. By putting the house under a specific pressure, we can measure exactly how much air is leaking in through all the little cracks and holes you can't even see.
We've seen the crummy insulation. We've seen the sketchy water heater. The clues are pointing to some big problems. But the real question is, just how bad is it? What did the numbers actually say?
And let me tell you, the results were, well, they were staggering. This is where we find the smoking gun, the undeniable data that just blows the case wide open and shows you the true scale of the problem. 1,716. That's CFM, or cubic feet per minute. And get this, that's not the leakage for the whole house. No, that is just the amount of air leaking from the ductwork alone.
You're looking at the actual reading right there. Now, to put that 1716 CFM number into perspective, a typical air conditioner for a house this size might move, say, 1,200 CFM of air total. So, you've got more air leaking out of the ducts than the system is even designed to deliver. You're literally paying a fortune to heat and cool your attic and basement. It's insane. And believe it or not, that's not even the worst part. The blower door test for the entire house came back at 16.3 ACH 50. That stands for air changes per hour at 50 pascals. It means when that test was running, the entire volume of air inside this home was getting swapped out with outside air more than 16 times every hour. For comparison, a tight modern home, it might be around 3. This house isn't just leaky, it's practically a screen door. So what does a number like 16.3 actually mean in the real world? It's pretty simple. It's the same as having a 2-foot by 2-foot window smashed out and just left wide open. All day, every day, 365 days a year. No wonder they can't get comfortable, right? You're literally paying to air condition the neighborhood. Okay, so now we know exactly how bad it is. We have the diagnosis. So, what's the cure? It's a strategy we call permanent load reduction, or PLR. And the whole idea is you fix the house first. The equipment comes way later.
And this right here is the golden rule for this kind of work. Prescription without diagnosis is malpractice. Think about it. Just throwing a new furnace in this house without fixing these massive leaks? That's not a solution. You're just putting a fancy new bandage on a gaping wound. So here's the battle plan. It's super straightforward. First, you get up in that attic and you seal every single little crack and hole between the house and the attic. Step 2, you blow in a nice thick blanket of new insulation. Step 3, you go after those leaky ducts and seal them up tight. And finally, you have to make sure that water heater is safe and venting properly no matter what. So you do all that. What happens? Well, you fundamentally change the physics of the house itself. And that completely changes the game when it comes to picking out the right HVAC equipment. This is the big payoff.
And this just lays it all out perfectly. You've got two possible futures for this home. The old school way, slap in a huge, oversized unit to try and keep up with all the problems. You'll still have high bills, you'll still have comfort issues, and you'll still have safety risks. But the PLR approach, you fix the house first. Now you can install a smaller, way more efficient system that's sized correctly. What do you get? Lower bills, a comfortable home, and, most importantly, a safer home.
So the next time you feel a draft or you're looking at a crazy high energy bill, it's worth asking yourself this question. Is your home's HVAC system just a Band-Aid on a much bigger problem? Because as we just saw, the real path to comfort and efficiency is often hidden in the parts of your house you rarely even see.